Hello everybody. Today we are going to study decomposing a resultant fraction into its partial fractions. The resultant fraction nx over dx, where nx represents the numerator and dx represents the denominator. However, there is a condition that denominator should not be equal to 0. We will be studying 4 cases. The first case says that denominator consists of non-repeated linear factors, or they may be reducible quadratic factors. The second case would be the denominator consisting of repeated linear factors. Third says that the denominator consists of non-repeated irreducible quadratic factors. However, the last one says denominator consists of repeated irreducible quadratic factors. Students, keep in mind, while decomposing a resultant fraction into its partial fractions, you have to check whether the resultant fraction is a proper fraction or an improper fraction. Remember, if the resultant fraction is a proper fraction, then you would continue solving it. Otherwise, if it is an improper fraction, first you have to convert it into a proper fraction, then apply the steps of resolving a resultant fraction into its partial fractions. Now we would be considering case A, where dx consists of non-repeated linear factors. Consider an example. We have a resultant fraction that says x minus 11 over x minus 4 multiplied by x plus 3. So first of all, we have to check whether it is a proper fraction or an improper fraction. We come to know that the numerator has the degree 1 while the denominator has a degree 2. Therefore, it is a proper fraction. Now we start solving this fraction. We would be writing is as let x minus 11 divided by x minus 4 into x plus 3 is equals to a over x minus 4 plus b over x plus 3. The logic behind this solution is we have to keep constants above the partial fractions. The degree of the numerator would always be lesser than its denominator. If we have degree 1 in the denominator, the numerator would be a constant, or it is a variable having degree 0. So this is our equation number 1. In the second step, we multiply both sides of equation 1 by x minus 4 into x plus 3. Now we get x minus 11 equals a into x plus 3 plus b into x minus 4. Since multiplying by x minus 4 into x plus 3 cancels out the denominator on the left hand side, and on the right hand side it cancels out x minus 4, which is the denominator of a, and x plus 3, which is the denominator of b. We name this equation as equation number 2. So now, for finding the value of a, we have to look at the denominator of a in equation 1, which is x minus 4. We put its denominator equal to 0 and get the value of x, which is equals to 4. In equation 2, remember we used equation 1 to get the value of x for a, and we are going to put this value in equation 2. So now our equation 2 would become 4 minus 11 is equals to a into 4 plus 3 plus b into 4 minus 4. So we get minus 7 equals a into 7 plus b into 0. You get minus 7 equals 7a plus 0. So here's the key point. If you're going to find the value of a, b will eventually become 0, and vice versa. If you're going to find the value of b, a will become 0. So now we have minus 7 equals 7a minus 7 over 7 equals a, or we can say that the value of a is minus 1. Now for b, we are going to use equation 1 again. We have to put its denominator equals to 0. We get the value of x, and we will put it in equation 2. Now we have minus 3 minus 11 is equals to a into minus 3 plus b into minus 3 minus 4. So remember that I told you that when you will be finding the value of a, the other coefficient, the other constant will become 0, and when you will be finding the value of b, its other counterpart will become 0. So here we have minus 14 is equals to minus 7 into b, minus 14 over minus 7 is equals to b, so the value of b comes out to be 2. Finally, we are going to put the values of a and b in equation 1. So our required partial fractions are x minus 11 over x minus 4 into x plus 3 equals the value of a, which is minus 1 over x minus 4, plus the value of b, which is 2 over x plus 3. Remember, students, it doesn't matter if you write a over x plus 3 and b over x minus 4. You will eventually get the same answers above your denominators. The use of letters is not that much important. You have to follow the required steps. Now we take another example, that is 3 over x square minus 1. Here we have a proper fraction again, but the denominator consists of quadratic factor. We can write it as 3 over x square minus 1 equals 3 over x plus 1 into x minus 1, which is an example of repeated, or we can say it as reducible quadratic factors. We can simply solve it by the previous method that says a over x plus 1 plus b over x minus 1, and you can simply solve it further. Another example is there of reducible quadratic factors that says 4x over x squared plus 2x minus 3. What can you do here is you can factorize the denominator, that is 4x over x squared plus 3x minus x minus 3. That comes out to be 4x over x into x plus 3 minus 1 into x plus 3, which equals 4x over x minus 1 into x plus 3. Again, you can solve it further, resolving it into partial fractions that are a over x minus 1 plus b over x plus 3. So these are all the possible cases when the denominator consists of non-repeated linear factors or reducible quadratic factors. And also keep in mind that the resultant fraction is a proper fraction. Now we move on to the case when the resultant fraction is an improper fraction. So what do we do here? Let's say we have an example, 6x cubed plus 5x squared minus 7 over 3x squared minus 2x minus 1. The degree of the numerator is greater than the degree of the denominator. First of all, we convert it into proper fraction, that is, we divide the numerator by the denominator. So what do we have here? We get 3x squared into 2x to get 6x cubed minus 2x into 2x. We get minus 4x squared minus 1 into 2x. We get minus 2x. Changing the signs of the terms, we get 9x squared plus 2x minus 7. Since the degree of the remainder is equal to the degree of the divisor, so still the fraction is not in the form of proper fraction. We divide it further, that's 3x squared into 3. We get 9x squared minus 2x into plus 3, we get minus 6x minus 1 into plus 3, we get minus 3. Changing the signs of the terms, we get 8x minus 4 as a remainder. Now we can see that the degree of the remainder is lesser than the degree of the divisor. So now we can write our resultant fraction as 6x cubed plus 5x squared minus 7 over 3x squared minus 2x minus 1 equals 2x plus 3, which is the quotient, plus 8x minus 4 over 3x squared minus 2x minus 1. When converting an improper fraction into a proper fraction, we get a proper fraction, along with the polynomial expression, or it may be an integer. So we say this as our equation number 1. So now we have to make partial fractions of the term consisting of the proper fraction, that is 8x minus 4 over 3x square minus 2x minus 1. We can factorize its denominator as 3x square minus 3x plus x minus 1. We get 8x minus 4 over 3x into x minus 1 plus 1 into x minus 1, and we get 8x minus 4 over 3x plus 1 into x minus 1. And now finally we can write it as, let 8x minus 4 over 3x plus 1 into x minus 1 equals a over 3x plus 1 plus b over x minus 1. And now we can apply the same method of solving a resultant fraction when denominator consists of non-repeated linear factors. We will be studying other cases in my next lecture. Thank you.